Okay, I'm going to talk about finding the distance. Well, we found the distance quite a bit during this early part of the geometry school year, and so hopefully by now you're starting to feel more comfortable with it. But there's a lot going on that I'm hoping you're recognizing, and we found slope and we found distance, and I want to take 2 points. Let's say 3, 8, and 7, 6. I'm just going to take 2 points, and I want to try to find the distance from those, and I'm going to show you how to find the distance from finding the slope. Okay, so we're going to find the distance, but we're going to use slope to do it. There's some benefits to that, especially with coordinate geometry, so it allows us to do a lot of things. So the way that I showed you guys to find slope is called the jumper cable method. So we're going to find the slope first. So I'm going to connect the y's on top and the x's on bottom. Point to the smaller on top, point the same direction on bottom. Slope is a fraction and slope is subtraction. So I set up my slope form, and then I just fill in the values as I've connected them. So connect the ones on top, 8 minus 6, 3 minus 7. When I do the subtraction on that, I get 2. 3 minus 7 is negative 4. All right, so the slope, the slope would be negative 1/2. So here's the key on when you're going to find the distance when you're using the slope formula. You never would use the reduced fraction. You're going to have to use the absolute value fraction. All right, so this number that I've circled, this now allows me, if you take the top number and the bottom number and you square them and add them under the radical, that's the distance. Okay, and so the distance in this case would be 4 plus 16. It's the square root of 20. And when you reduce the square root of 20, or not reduce, but simplify, and you would take the 2 out, it would be 2 root 5. The distance is 2 root 5. The slope, you would reduce it, but remember, if you're using the slope to find the distance, don't use the simplified or the reduced version of that slope. You have to use the absolute value. All right, so I'm just wondering what this looks like on the graph, because I'm trying to tie all this stuff together. I know this a lot, but I'm hoping it'll help clear up what you guys have been struggling to figure out, or hopefully considering, and hopefully you're fascinated by all this, because it's pretty neat the way it works in the coordinate plane. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. There's 3, 8. And then 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. So there's my there's my line on the graph. I'm just putting it on here so we can now see what we've already done. You don't necessarily need this. I like to have the graph so that it makes sense. Now, if I'm going to try to find the slope of this thing, I would use the rise and the run, which is 2 and 4. And notice that the line is going downward, so the fact that it goes downward tells me it's negative, and that would be 2 over 4, which is negative 1/2. All right, and then remember to find the distance. It is, the formula I've been sharing with you is horizontal movement squared plus vertical movement squared, and there's those same values. You might have been noticing that those same values continue to show up. So this is 4 squared plus 2 squared, which is 20, which we just showed that that's going to simplify to 2 root 5. So that's how you find distance using the slope formula, and that's all of it shown on a graph. So I hope that will help you to understand distance and slope a little bit better. There's some value in this because it helps us with determining parallels and perpendiculars and a whole lot of stuff that we do in geometry. So there you go.